Welcome to the office. I want to take a quick overview look at some theorems and definitions. These theorems and definitions are not crucial to the overall content coverage and our understanding for what we desire out of this particular course, but they are mentioned by our textbook. So I thought I would just kind of give you a preview, give you an overview of them, and then we'll move on from them. So I don't think that we want to cover any really significant examples. So a simple group, these are interesting, which we'll talk about in just a second. Right? How are simple groups interesting? Well, a simple group, a group is simple if it is non-trivial and has no proper non-trivial normal subgroups. Okay, that's a bit of a mouthful there. A group is simple if it has no normal subgroup. Right? That's the idea. That's the basic statement. The problem with that statement is that every group has the normal subgroup of just the identity and the normal subgroup of itself. Right? So we will always have those two normal subgroups, and we're just saying it has no normal subgroups other than those two. Okay. We also want it itself to be non-trivial, and of course, that has to be the case if we want to even have the possibility of a non-trivial subgroup at all. Okay, I think we're good now. Simple. An example of a simple group is any one of the alternating groups. So that's just an example for now. Again, simple groups are interesting because if they have no normal subgroups, that means that you cannot find a factor group with these, right? You can only get a factor group by taking group mod normal subgroup. Well, there's no normal subgroup, so you can't do anything with it in terms of that. So you can't really condense it or compress it in any way through this modular, right, modulo whatever normal subgroup. All right. This theorem is discussed primarily as a way to consider the following theorem, I believe, definition and theorem. So this is interesting information, or at least mildly interesting. It's interesting enough because it just deals with homomorphisms and, again, normal subgroups. So what we want to know is that if we have a homomorphism of groups, and N is a normal subgroup of G, we already know that the image of subgroups is a subgroup. So an image of a subgroup here will be a subgroup there. But the difference that we want to say in this particular theorem is that the image of a normal subgroup is also normal, but it's not a normal subgroup of G prime. It's a normal subgroup of the image of G. So that's a little bit different than what we had seen previously. And of course, this works the other direction as well. If N prime is a normal subgroup in the image, then its pre-image is also a normal subgroup. So interesting information there. I'll actually ask you to take a look at one of these aspects, either the forward direction or the reverse, in your homework or suggested problems. All right. And then the last thing that I want to mention in this is just a classification of these simple groups. So a maximal normal subgroup of a group G is a normal subgroup. So a normal subgroup, and I want it to be the maximal one. Let's see here. It's normal. Is a normal subgroup maximal? Yep. Okay. A maximal normal subgroup of a group G is a normal subgroup which is not the entire group, such that there is no proper normal subgroup N of G properly containing M. Whew. All right, so if I have a group G and I have the maximal normal subgroup, then there might be other normal subgroups in here. That's fine. Actually here. Yeah. Okay, so if we have a normal subgroup, it is the maximal if no other normal subgroups contain it. So technically, maybe you could have two maximal. It is a maximal. Yeah, a maximal subgroup, not necessarily the maximal normal subgroup. All right, if I found a normal subgroup that contains all of those, then those would not have been maximal, and the one that contains them is. All right. I think that's what we're looking for. Now, M is a maximal normal subgroup of G if and only if G quotient by M is simple. Yay! I'm not sure that that really helps us understand what's going on, but it's something anyway. So again, what we've talked about in this video is essentially just a nice preview or overview of several topics, simple groups, maximal, normal subgroups. Okay, cool. That gives us some information. Overall, we're not really desiring to bring that into what we need to know right now, but this kind of theorem that helps us move along the way is also nice to be aware of. All right, so let's take a look at a couple more definitions and a couple more examples. So join me back here in the office in just a moment.